This video is particularly for the A-level students, and this is the first of the paper 5 videos which I'm making. This is particularly for question number 1 because that's the question where a lot of planning and discussions has to happen. Paper 5 was first introduced in 2007, and this paper is worth 30 marks. There were 2 questions of 15 marks each. And the first question is planning and evaluation, planning and analysis, and the second question talks about the evaluation of the data. Now, evaluation of the data, the second question is something which is quite easily done by most of the students because it's all about making graphs and making analysis and deductions from it. But it's the first question which needs a lot of discussion, a lot of creative thinking. If you remember your IGCSE paper 6, the last question there, the planning question that you used to do for 4 to 6 marks, well, it's the same kind of idea which is now brought up to 15 marks now. So what I'll do is I'll take you through the first question of June 2007, paper 5. So before I start, why don't you pause the video for a while, get a hold of that paper, have a look at the questions, and so that we can go together. In fact, what I would advise you would be, why don't you read ahead, go through the earlier information given in the first question, go through the first couple of parts, and prepare some kind of responses from you, and then try to match it with the responses that I speak. That will be great. If you look at the question, it talks about the reaction between acid and a metal to produce salt and hydrogen. And it wants students to think about how the rate of this reaction is affected by changes in the concentration. It would be good for you if you just try to recollect what you've learned in grade 9 and 10, how concentration affects the rate. Based on that, it will be quite easy for you to answer these questions. But what I would advise you would be, before you go on, continue watching the video, why don't you pause this video for a while and try to write your own answers and then try to match it with what I'm trying to discuss. Okay, assuming that you have the answer to question 1A, first part ready, it talks about how would you expect the rate of formation of hydrogen be affected by changes in concentration of the acid. So the correct answer for this kind of question is that the rate of formation of hydrogen increases as the concentration of the acid increases. That's all. They don't want any explanation. The main point is just how connect the concentration to the rate of connect the concentration to the rate of formation of H2. The more the concentration, faster the rate of H2 formation. That's it. That's the only answer required for this question. When you go to the next one, it talks about how temperature can affect the rate of the formation of H2. Well, based on the kinetic theory of gases, what you studied earlier, temperature affects the rate directly. If you increase temperature, kinetic energy increases, collision increases. But you don't need to explain that in detail. The question just wants you to connect the rate with the temperature. So a simple answer, that higher the temperature, faster the rate of reaction would be a simple response to this question. Then moving on to part B, it talks about in an experiment to determine the rate of the reaction with respect to HCl, identify the independent variable. Well, independent variable is basically something that we would change in an experiment to investigate how that affects the rate. And that's the data which usually comes on the x-axis when you draw a graph. Now, what you're trying to do is to understand how concentration affects the rate. That means that's the correct answer for this question. What does identify the independent variable? It means what are you going to do to investigate how the rate of reaction is affected? You're changing the concentration. So what you're changing is what's the answer of this question. So that's why the correct answer is concentration of HCl. The C part talks about identify one variable other than the temperature that must be controlled in the experiment. Because you're only investigating the effect of the concentration on the rate of reaction. So you don't want any other factor to interfere with that experiment or with that investigation. So the things that you, and the question already spoke about temperature earlier on. And it also clearly says other than temperature. What else would you want to make sure it doesn't change during this in this experiment? Well, you could talk about the volume of the acid. You could talk about the quantity of magnesium you will take, because if the quantity of magnesium is not the same, you wouldn't be able to compare the results. If the volume of the acid is not same in all the experiments, your data would not be correct. You could talk about the length of magnesium ribbon. You can talk about the mass of magnesium, and of course the volume of the solution itself, because that's the one which is going to gain the heat. So any of these could be a simple answer. Volume of the acid, the mass of magnesium, length of magnesium, size of magnesium, surface area of magnesium would be all these answers. In fact, if the question had asked you how would you ensure that the surface area remains the same, in that situation, instead of taking a strip of magnesium, you probably would have taken powdered or crushed magnesium just to make sure that the surface area remains the same. This part, D part, happens to be the one which needs maximum discussion and our attention, because this is the crunch part of the entire question. This is where your thinking skills, your in-depth knowledge of presenting the data, your accuracy of your statements in terms of different data that you would propose is what is going to be tested. Also, this is a good opportunity for you to to impress the examiners with your clinical accuracy, as we say. So I would advise you to, why don't you read this part for a minute or two, try to digest all the information they have given you, see the marks which is allotted, and then come up with some kind of a plan. What I would advise you would be, I'll give you some parameters, and I would want you to work on those parameters, collect some information from your side, and then we can have a discussion as to how best we should be able to answer this question, because I don't want to give out the answers at one go immediately. So I'll give you certain parameters that will help you to understand how to develop this answer as you go along. If you look at the number of points given, there are 6 of these points, and you've been given magnesium ribbon. That's important, which means you have some kind of a strip of magnesium. You don't have powdered magnesium. You have been given an acid whose concentration is 2 mole per dm cube. Notice that there is no definite volume of the acid given. That means you are allowed to use whatever you want, how much ever you want. They also have not given you any definite amount of magnesium, which means again you're allowed to use whatever you want. And then if you look at the entire 6 things what they have given you, they did mention that we would like to see a list of apparatus you would want to use, which means it would be good if you can think of some kind of a diagram, and when you draw the diagram, try to label all the apparatuses, and that will obviously help you to get around that particular point. What you are expected to do is to write a comment or 2 on each of those points what they have been mentioned. So clearly you need to mention something about the apparatus. So draw a diagram, try to list out the apparatus, and when you list the apparatus, also try to figure out some kind of volumes of those apparatus. So I'm not suggesting any name at this point of time, but whatever apparatus you select, try to give me some volumes that you would want to use. Second point talks about how would you measure the independent variable. Remember, the independent variable what we spoke about was the concentration of acid. I mean, how would you change it, or how would you measure it? And how would you ensure that it's being measured accurately? Now this is important for you to understand. That means when they say something like that, it means how would you ensure that the volumes or whatever you're recording is accurate, which means emphasis is given on the name of the apparatus that you would use to make sure that that volume is correctly measured. The third point talks about how would you mix the reactants without the loss of gas from the apparatus. So either in the diagram or stated otherwise, you need to mention this about this. You need to write a comment about this, is what they want. So which could include, if it's very clearly mentioned in your diagram, and I as a teacher is able to pick it up, that means you don't have to write anything on it. But if the diagram is not in place, which obviously means you need to write a comment clearly explaining to the teachers as to how would you make sure that no gas escapes. Because otherwise what will happen is your volumes of gas that you measure is obviously not correct, and which again brings error in your experiment. The fourth point talks about how would you measure the dependent variable. Now this is important. Dependent variable is something that you're going to measure, and that's the value which goes on the y-axis when you make some kind of a graph. Which again means we are not telling you what would you like to measure. So you have to think of this one. What would you like to measure? How would you like to? What apparatus do you need to measure? And once again, you need to state the volumes of the apparatus what you have selected. And this information helps you to prepare your graph. When you draw the graph, you have data on the y-axis, you have data on the x-axis. You always have to keep that in mind, because you would be probably asked in the next page, how would you process that information? Then the fifth point talks about how would you control the other variables. Now this is what we spoke about in the previous page. How would you control other variables, which means they're not telling you which ones, but what they want to from you is they want you to make sure that you know temperature effects. And then what we spoke about in the previous page, we spoke about the amount of magnesium, the length of magnesium, the surface area, the volume of the acid. So how would you all make sure that they do not change in your description here? Otherwise, they will also contribute in making your data wrong. And the last point talks about appropriate quantities. Now this, in my opinion, is one of the most trickiest point, because when they say appropriate quantities, they are not telling you, they actually want from you to have some kind of a logical deduction as to how much magnesium would you take, how much acid would you take. And that's an open-ended point, because everyone probably will think differently, and it's very important for you to talk numbers which are sensible, numbers which are logical, which can be easily manipulated in a lab situation. So obviously talking about a few kilos or meters of magnesium ribbon doesn't make sense, or talking about a few liters of HCl doesn't make sense. So you need to talk about certain quantities which are taken in very small amounts, which you've been used to when you were in AS classes last year when you did your AS practical sessions. So think of the quantities what your teachers used to give you during those lab sessions. That will help you to understand, of course, or there could be some other way to figure this out as to how much appropriate quantity of magnesium would you like to take, how much acid would, and what would be the justifiable reason as to why have you taken those. So these are the parameters. So what I would suggest is, why don't you pause this video for a few minutes, think about it, and prepare some kind of comments on each of the things which I spoke. You could rewind it later and have a look at it and hear it once again. Once you have your rough work ready, then you would be in a much better position to actually start framing a good answer for this question. So make sure that you have comments for each of those points which I spoke about. And then all it takes is to compile them and make a very good impression on the examiners. So pause the video for a while, and then we'll continue our discussions. So using a thistle funnel there, and also a delivery tube, both of them going through the bung into the conical flask, or a hot boiling tube, which is then connected to the gas syringe, would be a simple diagram for this. Let's have a look at the, once we are okay with our apparatus list, and in our apparatus list, as I said earlier, it's always good if you could mention the volumes of the glass that you're going to select. Now, for example, if you say graduated gas syringe, you could start with 500 cm cube. You could take 1 dm cube, or well, some of the old marking schemes does allow up to 5 dm cube, but that probably is too much. But at least you could go for 1 dm cube. You can go for 2 dm cube, I guess. But a 1 dm cube gas syringe would be a standard volume that you can think of. And as far as the conical flask, in case you're going for a conical flask, try not to take a very big conical flask, because then the gas pressure would not be too much for the gas to be easily pushed into the gas syringe. 100 ml conical flask would do just fine. 75 cm cube is, in my opinion, much better. And then comes a very crucial question about the appropriate quantities. Now, it's very important for you to understand you cannot just guess the amount of magnesium that you need. I mean, you cannot just say, I'll take 5 grams or 10 grams or 20 grams. You need to give some kind of a justification as to why you did that. So what you could do is, you could look at the volume of the graduated gas syringe, because that would be a limiting factor. That's the maximum amount of gas that you would want to produce in the reaction. Now, if your gas syringe can hold, let's say, 1000 cm cube of hydrogen, you can't just go on and say, I'll take 50 grams of magnesium or 50 cm length of magnesium. You can't do that. You need to measure some kind of a mass of magnesium. So what best you could do is, you could assume that the maximum hydrogen gas that you would produce in this reaction, let's say, is 1000 cm cube, depending on the volume of the gas syringe that you've taken. And that will be the amount of gas produced by the highest concentrated acid in a certain time interval. Let's say for the entire 5 experiments, you're trying to fix the time as 1 minute. You have to do 4 or 5 experiments, and each experiment, let's say, you do only for 1 minute. So in 1 minute, the most concentrated acid will produce the highest amount of hydrogen. That's the simple logic. So the maximum amount of hydrogen you want to ensure which produces in your experiments should be the one given by the most concentrated acid in 1 minute, which could be close to 1000 cm cube. So using the formula N equals to V by 24, you could convert that information into moles of hydrogen gas. So I'll wait for you. Why don't you assume, let's say, maximum volume of H2 produced equals to 1000 cm cube, and use the formula N equals to V by 24. Do not forget to convert the cm cube into dm cube by dividing it by 1000. And then find the moles of the H2 that you think would be produced as a maximum quantity. And once you do that, N equals to V by 24, once you finish that, the moles of hydrogen, now you need to connect this with the moles of magnesium. If you turn the page over, look at the equation of magnesium plus HCl gives you magnesium chloride plus hydrogen. Now try to see the mole ratio between magnesium and hydrogen. In that balanced equation, it is 1:1. Magnesium is the limiting factor there. So you need to connect this to the moles of magnesium, which, because it's 1:1, it turns out to be the same. Now you have the moles of magnesium, you know the atomic mass of magnesium. You can use this information to find the mass of magnesium using the formula mass equals to moles times AR of magnesium. And once you do that, you will actually find the mass of magnesium. So pause the video for a while, finish all this calculation. So step 1, find the moles of hydrogen using N equals to V by 24. The volume must be in dm cube. Use that to find the moles of magnesium. Use that moles of magnesium to find mass of magnesium. And once you're ready, then it will continue from there. Well, I hope you've found the mass of magnesium, and you might be surprised by the answer that you're getting. And imagine if you had selected 20 grams of magnesium or 30 grams of magnesium, that would have been way off your target. And that would have produced so much of hydrogen gas, which obviously is much more than the quantity of the gas syringe that you've selected. And your experiment would have had errors in your answers. So that's how they take care of the appropriate quantities. That obviously needs a lot of thinking, and as a senior in grade 12, you are expected to think this way and to arrive at a certain logical number. So once you're done with the mass of magnesium, now obviously you need to set up your first experiment, which means you will measure that mass of magnesium. And again, one of the points said, how would you ensure that all measurements are accurate? Which means you cannot just say, I'll measure so much mass of magnesium. You have to tell us the name of the apparatus, what you will select, or top pan, a digital top pan balance, capable to measure 3 decimal places, because the amount of mass that you're measuring is very low. So you need a very high caliber top pan balance. You cannot just use a 1 decimal top pan balance. That would not give you the appropriate mass that you need for. So using a top pan digital balance capable of measure 3 decimal places or better can be used. That's to confirm that the mass of magnesium is accurately measured. Draw the diagram. You can just say set up the diagram set up the apparatus as shown above. So you don't have to describe the whole procedure of how would you set up the diagram. So that's the good thing of making a diagram in your essay. So you could just write one comment. We'll set up the apparatus as shown in the diagram. That saves you a lot of space. And then you do your first experiment. When you have a certain amount of magnesium in it, what you need to do is to measure out a certain amount of acid how much acid would like to take? I mean, you could take 50 cm cube of acid, you could take 100 cm cube. Now, since normally in AS lab sessions you always work around about 50 cm cube of the acid, so you need to measure 50 cm cube of the acid. Once again, in your essay you need to mention the name of the apparatus that you will select to measure the volume of acid. And how would you ensure its accuracy? You could use a beaker, but then that's not very accurate. It has a lot of error in measurement. The other two options are burette, or you could measure using a pipette, but then that's much suitable for titrations. So using a burette is a much better option compared to a measuring cylinder. So compared to a measuring cylinder and a burette works much better, it's much more accurate. So I'm going to use a burette to measure 50 cm cube of the acid. And we'll start the first experiment, and I'm going to fix the time for 1 minute. And in 1 minute time, I'm going to record how much H2 gas is collected in the syringe. Once that's done, remember, our intention is to change the concentration of the acid and see how does it affect the rate. So in my second experiment, I need to make the acid mode less concentrated. So using the concept of serial dilution, but also to make sure that the total volume remains 50. So to make it 50, so I'm going to take 40 of this acid and I'm going to add 10 cm cube of distilled water into it. So I can use two burettes, one for water and one for the acid. Take 10 of distilled water, take 40 of the acid, mix them together. So I still have 50 cm cube as my total final volume, and I'll repeat the experiment again using the same quantity of magnesium. In my third experiment, I will take 30 of the acid, 20 of the water. In my next experiment, I'll take 20 of the acid, 30 of the water, and the last one, 10 of the acid and 40 of water. So what we have done is we have successfully changed the concentration of the acid over the 5 experiments. Now obviously the time taken for which to record the amount of H to produce is constant in all of them. It's 1 minute. And the acid at the end, which is the least concentrated acid, will be producing the least amount of hydrogen. So that way I could compare the amount of hydrogen collected after every 1 minute in all these 5 experiments. And I can see that as the concentration is decreasing, this is called relative concentrations, RC. Relative concentration is you could find the RC value for each acid by dividing the acid volume divided by the total. Now that means RC for the first experiment was 50 over 50. You have 50 of the acid and 50 total volume, so RC was 1, relative concentration. In the second experiment, you took 40 of the acid and divided by the total quantity, which was 50. So you get RC is 0.8. In the third one, you had 30 of the acid, so that's 30 divided by 50, RC is 0.6. So you're trying to highlight the fact that as you decrease the amount of the acid in each experiment, since you kept the total volume same, the relative concentration kept on changing, and that affected the amount of the hydrogen gas collected in this range directly. So this way we do that, and of course you also need to mention in your essay how did you keep the other parameters same, how did you keep the temperature same. So you may want to do this experiment, maybe you can submerge the conical flask and keep it in a water bath with thermostat control. That's a simple option. Easy option to make sure the temperature is constant. You made use of the top band balance to measure correctly the mass of magnesium. So all those inaccuracies can be taken care of. And of course certain precautions which are required as you keep doing this experiment. You're handling the acid, so use of gloves. You're doing an acid metal reaction, use of safety goggles, and lab coat is always recommended. Well, that was basically how this question had to be written. There's so much of detail that just goes to prove that how much in-depth knowledge the examiners expect from you, and you being a senior have to think in a very clear, logical terms of the numbers, of the volumes, or the names of the apparatus. And it's not just enough to just casually mention your answers. You have to be very specific in your answers. On the next page, the E part of the question says, prepare a table that you could use to record all of the data from the experiment. Include columns for processing the data. Record it. Explain how could you use the data to confirm or reject your prediction. Well, to make a table and to write a comment on exactly what would you do with the data. Well, to make a table, once again, it needs clarity of thought, on students' point of view, because only when you know what you're trying to collect, you could actually make this data to make this observation table very easily. Most students, sometimes they don't know what they're trying to record. So since they don't know what they're recording, so it's very difficult for them to construct this kind of table. So first of all, of course, you need a table which shows all the experiment numbers, experiment number 1, 2, 3, 4, 5. And then what did you change? You kept the mass of the magnesium same, so that doesn't have to be on your table. But what did you record and change? You changed the amount of the acid. You changed the amount of water. So which means your column should clearly say volume of the HCl slash cm cube. Don't forget the unit. And then for each experiment, 50, 40, 30, 20, 10, write down the volumes. Then you also change the volume of water. So volume of water slash cm cube. In the first experiment, you took 0, and then of course 10, 20, 30, and 40. You also, of course, your volume of H2 collected, volume of hydrogen slash cm cube again. You could leave this blank, but you could also put some numbers. There is marking schemes of, if you can look at it, they don't suggest anything. I mean, they just look at, as teachers' point of view, we just look at your logic and your reasoning, that's all. I mean, even if you leave it blank, it's fine, but I guess I would recommend if you just put some numbers there. Because they did say, how do you process the data? So you could just mention, and obviously we expect you to understand that the first experiment, which you did with 50 cm cube of the acid, will produce the maximum hydrogen. You could start with 1000. And then you can keep reducing those numbers in a very, again, logical way, having a fair share of difference as you go down, and that will suffice. And by the end, and at the end of the couple of lines given, so you could mention, okay, how would you process this data? Explain how could you use the data to confirm or reject your predictions. Explain how would you use the data. So you could comment on the making of some plot of graph of the volume of hydrogen gas collected against the concentration of the acid, because you kept the time interval same. So by making a plotting a graph of hydrogen gas collected on your y-axis, that's the dependent variable, and what you changed was the concentration. You could mention RC, relative concentration, there. So, and then you'll get some kind of a graph, plot a graph, and you could find the rate from there. That's one thing. But anyway, since the question never asked you to calculate rate, they just wanted to understand how the effect of concentration affects the rate of formation. So that would be enough by just writing one statement. The F part talks about describe how would you alter the method to investigate how the rate of reaction varies with changing temperature. Well, now the question says we want you to think of how temperature affects the rate. It means all the other parameters must be kept constant. So no more changes of concentration of the acid. That means all the 5 experiments you're going to take the same amount of the acid. But now, since only temperature has to be changed, so you could carry out this experiment once again using a water bath with thermostat control, where you could, or you could heat acid at different temperatures, change the temperature of the acid before the acid and the magnesium comes in contact. So you could do the first experiment. Again, you have to be very careful. I mean, if this question comes to you in form of a big description question, I'm just trying to make a background out of it. Your first experiment will be at room temperature. And if you have to make 5 experiments with increasing temperature, you must understand that there's a certain point after which you cannot go for safety reasons. So don't end up boiling the HCl. So that means if your room temperature is the first experiment, I would advise you to go 5 degrees more for the second one, another 5 degrees more for the third one. So the increase of temperature again has to be gradual. So the maximum temperature where a student would be made or allowed to work in a lab would be around 65, 70 top. It will not definitely be more than that. So it's always good to increase temperature gradually. So yeah, here your simple answer could be the concentration of HCl would be kept constant, and temperature is going to be varied by using water bath with thermostat control or heating HCl to different temperature levels, and again recording the volume of hydrogen gas collected at different temperature values taken, keeping in mind that each experiment 1 minute was given to record the volume of H2. So in every 1 minute, a higher temperature obviously would end up producing much higher amount of the hydrogen gas. That's about it. This was the first question for May, June 2007. I hope you have some idea about how to think. It's all about your clinical accuracy. It's all about your logic. It's all about how in-depth answers you can think of. So I would advise you, please do not rely on the marking schemes as your source of information. So look at the parameters what I talked about. These are the parameters what you have to keep generally same for almost every question, every first question of the paper 5. I hope this video was useful for you, and I hope in times to come ahead I'll be able to make more videos for paper 5 first question that might give you some help. Alright, all the best. Thank you very much.